Alright, so what I have here is I have an irregular shaped object. And what I want to be able to do is I want to be able to find the perimeter and the area of this strange object. Okay, so for perimeter, I always like to pretend I am the little guy walking the perimeter. Good old military days. Okay, where we simply walk around the perimeter. So I imagine, well, what happens if I walk from here to here? Well, I go 6 inches. Then if I walk from here to here, then I go 5 inches. Then I walk from here to here, I go 4 inches. And from here to here, we go 4 inches. And from here to here, we go 10 inches. From here to here, we go 13 inches. And then from here to here. Well, notice there isn't anything written here. So I have to figure out what that is. Well, since this bottom shape is kind of rectangular, we can assume that since from here to here is 10 inches, from here to here is also going to be 10 inches. So we will add another 10 inches to that. So our perimeter is going to be 6, 11, 15, 19, 29, 39, 42, 52 inches. Now for area, remember the area is the surface. We got to figure out what that is. Okay, so for area, we need to be able to break this thing into recognizable chunks. Okay, and I look at this and go, well, you know, if I had a line right there, up here I've got a triangle, and down here I have a rectangle. I go, aha, I have a formula for the area of a triangle. The area of a triangle equals 1/2 base times height. And the area for a rectangle is length times width. So, well, that means that if I find this area right here, I can add it to this little area here, and that will give me the total area of what it is I'm looking for. Okay, so I'm looking for total area. I put a little subscript here. You don't need to worry about that. That's just because of my OCD issues. Later on you'll learn about subscripts, but basically it's just a way of telling areas apart. So let's figure out what the area of this rectangle is. Well, it's simply going to be length times width, right? And then I'm going to add the area of the triangle, which is 1/2 base times height. So this is the total area that we're looking for. So what's length times width? Well, we've got a length of 13 and a width of 10, and you can call it the opposite, it doesn't matter. Plus 1/2 times base. Ah, well, what's the base of this triangle? We haven't figured it out yet. Okay? Now, we could rotate a triangle to make it look different. That's fine, and call the base something else, but we're still going to have to figure out this value right here. Okay? So the base of this particular triangle is this distance. The problem is I don't know, that distance. Problem is I don't know that distance. But I do know that from here to here is 13 inches, just like here. So if the total distance here is 13, and from here to here is 6, and here to here is 4, if I take that 6 and that 4 and subtract it from 13, whatever is left over here is going to be that distance right there. So I simply go 13 minus 6 minus 4 is 3. So that distance is 3 inches. Okay? So I now know my base is 3 inches. And my height, I'm using parentheses here, but parentheses, when you butt them up next to things, just means to multiply. And my height is this distance here. It's not the length of that hypotenuse there. Okay, it is from here. Oh, can't see that. It is from here to here. It is the actual height, not the longest side. And height is a 4. Okay, so now I can figure out my area. 13 times 10 is 130. 1/2 times 3 times 4, that would be 6. So the area equals 136. Now here's the important part, units. Since we're talking about area, we're talking about square units. And we're in inches, so this would be square inches. Or you could put inch squared, which is the way that I prefer to do it, but again, we're not quite there. Okay?